In this video, we're going to look at aromatic hydrocarbons. The big thing that you need to understand about aromatic hydrocarbons is how they differ from aliphatic hydrocarbons. On the diploma exam, this is really where the crux of your knowledge has to lie. Aliphatic hydrocarbons are hydrocarbons that do not contain a benzene ring in their structure. Aromatic hydrocarbons, for our purposes in Chem 30, are compounds that do contain a benzene ring in the structure. Now, there are other compounds other than benzene that lend aromaticity to chemicals, but in Chem 30, all we really care about is benzene. So, what is benzene? Benzene is a really interesting molecule. Its structure was a mystery for a long time. And generally, like, people understood the empirical formula of benzene years ago. Benzene was a product of tobacco and could be found in charcoal after a fire. It's a very toxic compound. It's a very stable compound. A lot of reactions that you can perform with alkenes that have double bonds in them, you can't do with benzene, which was a bit of a perplexing fact when people were trying to determine its structure. It's a very stable compound. And as I said, they knew the empirical formula. They knew that the number of hydrogen atoms equaled the number of carbon atoms. So they knew it was a very low hydrogen to carbon ratio compared to other hydrocarbons. So the structure took a while to determine. There is this legend that August Kekule, who was, I believe, a German chemist, had this dream of a snake eating its tail. And that's what led him to this idea that the benzene molecule looked like a 6-carbon ring, looked like a hexagon, with 3 double bonds in it and 3 single bonds. Now, that's not true. Benzene's a little bit more complicated than that. These Kekule structures are resonance forms of one particular molecule. And here you can see there's a 6-carbon ring, and there are 3 double bonds and 3 single bonds. That's kind of a model we use to kind of show a benzene molecule. And the electrons that are part of the double bonds, each double bond has 2 electrons in it, plus 2 from the single bond underneath it. Those electrons are free to move and circulate between the different carbons. So you can get a form over here on the left and then a form on the right where all the double bonds just move over another place. But really what's going on is that the bonds between carbon atoms in a benzene molecule have a length that is between the length of a normal carbon-carbon single bond and the length of a normal carbon-carbon double bond. So they're kind of like, the bonds are 1.5 bonds. They're not a single bond, they're not a double bond, they're like 1.5 bonds. In reality, the electrons that are part of these double bonds, the 6 electrons, are in a bit of a C or a ring. They're kind of in a delocalized system where they're able to flow between the carbon atoms on one side of that ring. So the structures that you need to know to be able to recognize, and the stuff you need to know for this course, are the following. So you need to know the molecular formula. You need to know be able to recognize that benzene sometimes is written as a 6-carbon ring with 3 double bonds in it. And probably the most accurate depiction of it is a hexagon with a circle inside. The circle showing that the electrons are kind of flowing between all the carbon atoms. Okay, so those are ones that you need to know. You don't need to know any of the other stuff with orbitals and all that kind of stuff for grade 12. So key points about benzene. Benzene does not have 3 single bonds between carbons and 3 double bonds between carbons. Each bond is approximately 140 picometers in length. That puts it between the length of a carbon-carbon single bond and between the length of a carbon-carbon double bond, right? So it's kind of a hybrid of a single and a double bond. All right, so a big thing that you need to do with aromatic hydrocarbons is be able to determine which compounds are aromatic based on the presence of a benzene ring. So maybe pause the video now and think about which of the following 4 compounds here are aromatic. Okay, so which of them are aromatic is really as simple as looking for the benzene ring. So this one here on the top left, I think this is vitamin E. The benzene ring can be found over here. So yes, it has it. It's aromatic. The one on the bottom here, it has a benzene ring. Therefore, it's aromatic. Bottom right has a benzene ring. It's aromatic. Top right looks close. This is a 6 carbon ring, but it has only 2 double bonds shown. If this were to be a benzene ring, it might have another line, okay, going here, but it's not. It doesn't have that. So this is not benzene. So it is not an aromatic hydrocarbon. So we would call this aliphatic. Aliphatic spelled like this, A-L-I-P-H-A-T-I-C. So if there's no benzene ring, we refer to it as aliphatic. How do we name aromatic hydrocarbons? Well, pretty simple. The parent chain is the benzene ring. So in this particular example, the parent is benzene, and I have 2 groups coming off of the ring at position 1, and this is wrong. That should say 3. So I've got 2 ethyl groups. So I've got 1 carbon here, 2nd carbon there. That makes this an ethyl group. And I've got a same group down here coming off of carbon 3. And you want to start numbering such that the branches have the lowest possible number. So I want to go from, what would this be? I think this would be clockwise. I would go clockwise direction here to get 1 and 3. You don't want to go the other way because then you would get 1, 2, 3, 4, 5. Yeah. So you want 1, 3 instead of 1, 5. So this would be called 1,3-diethyl benzene. All right, if the benzene ring is attached to a carbon chain that is 7 carbon atoms or longer, the ring then becomes a branch, and the parent is that carbon chain. So in this example, we've got 7 carbons in the chain, and the benzene needs to be at the carbon with the lowest possible number. So this would put it at carbon 2. When benzene is a branch, the branch is called a phenyl group. That's something you'll need to remember. It's a phenyl group. It's not a benzyl group. A benzyl group is different from a phenyl group. I know this is another layer of confusion, but something that you're going to have to just know. So the phenyl group is a benzene ring attached directly to the chain, and we call it a phenyl when it's attached to a chain that is 7 carbon atoms or more. So the phenyl group here is on carbon 2, so we call this 2-phenylheptane. And that's it for this video. We will be looking at aromatic hydrocarbons again in the future as we start looking at functional groups, but as I said earlier, the big thing that you need to know is being able to determine which structures are aromatic based on the presence of the benzene ring. And remember, the ring can look like a hexagon with a circle inside of it, and it can also look like a ring with 3 double bonds in it. Key point there, though, is that it isn't actually a ring with 3 double bonds and 3 single bonds. Those electrons are free to move between them, and those bonds are actually 1.5 like hybrids of single bonds and double bonds. All right, see you in the next video.